Hello, everyone. Thank you for tuning in to this episode of the Software Plaza podcast. I'm Twain Taylor, editor at Software Plaza. And if you like what you hear in this conversation, I want to encourage you to go and check out all the other conversations we've had. We've been doing this for a while. And we've even spoken to, well, today we're going to talk to one company that operates in the space of, well, databases is what they started with, but it seems like there's change in what the space is now. But we've featured another startup as well in the same space about a year back. So go and check out just what we've spoken so far on this topic. I'm really excited to be speaking today to Bob Van Lout. I hope I'm getting his name right.
Yes.
It's the Dutch pronunciation, apparently, and I like to give it a good shot with my guest names. So, I was in touch with Bob actually pre-pandemic when they were just starting out with Weaviate, and we did a couple of one or two pieces of tech writing together, just explaining the concept of Weaviate and vector databases. And at that time, it was really, really early stage. And today you probably, if you work in AI, if you work in Kubernetes, familiar with AWS, you build stuff, you've probably heard of vector databases. You've probably heard of Weaviate. But back in the day, it was brand new. No one had heard of this thing called
Yep.
vector databases. I think probably, Bob, was graph databases like a precursor to vector databases?
So first of all, thanks for having me. And I say you were definitely an OG there. So I wouldn't say that it was graph databases were before, but it's more that the back then, and this is very important for the people listening to keep in mind, right? This is we did not have ChatGPT yet. We did not have LLMs yet. We had these very basic language models. So back we started with GloV and those kind of things. And I thought back then that the first use case for this type of technology was entity recognition in knowledge graphs. So that's where that graph database angle comes from. But the database itself is not a graph database, but it could help with entity recognition in knowledge graphs. And that back then we thought that was like the main use case. Ironically, now we're now recording this the end of 2025. That went full circle because people now start to talk about that again. So I thought that was funny. Yeah.
Wow, wow, interesting. So yeah, so back then when it was brand new, nobody knew it. But then when I look at today, I look at like the kind of traction you had. You know, you raised Series B funding. There's just so much, there's so many. The open source project has a lot of traction. I look at your LinkedIn posts, and there's so much activity and just so much excitement around the project over the past few years. You really come a long way. Congratulations, just a lot of progress.
Yes, no, it's a well. First of all, thank you, and secondly, I remember that because I'm a I live in Amsterdam. I'm from Amsterdam, and people might know or not know is that another company, an infrastructure company that has roots in Holland is Elastic, and
Oh,
years
okay.
ago was that I years ago. So I had a cup of coffee with somebody who was like at that company really early, and so I told him like I want to start such a company too. And he
Mm-hmm.
looked at me and he goes like, "Are you nuts? Do you know how much work that is?" And I was like,
Mm-hmm.
"Well, a little bit. So let's just let's I'll just gonna give it a go." And now we are we're here like 6 years later, and he was not wrong. It's a lot of work,
Mm-hmm.
but it's also a lot of fun. So it's like it's you balance those two things.
Yeah, yeah, yeah. Wow. So yeah, so that was one memory. Anything else that
Yes.
you'd like to kind of bring back from like the origin days? What really got it started? Where did you get the idea from? Or what were some of the pivotal initial discussions you had when just starting up?
two companies that have been important in our journey were OpenAI and Google.
Okay.
So what happened was that at some point OpenAI offered this. Okay, now we need to go even some one step before that. So we have Weaviate. The
Mhm.
embeddings that we're using are single word embeddings. So they're coming from, we were using Glove and that kind of stuff. And all of
Mhm.
a sudden, we get, of course, the Transformers paper gets released, models gets trained on that, and all of a sudden we have these new models called sentence embeddings, which
Okay.
was just was like working perfectly well with what we were building. But now all of a sudden, stuff got like way better than what we already had, right? Now,
Mhm.
just after that, OpenAI released their embeddings endpoint, and on their website they said like, you can store these in in a vector database, and they listed like three options or something, and we were one of them, right, as an open source database, and that was very important for us. So a lot of people, that was where a lot of adoption started.
Mhm.
Then there was the then Google joined that, the space as well, and there
Mhm.
was a keynote during Google I/O,
Mhm.
and during the keynote at I/O, they talk about like partners in the AI ecosystem, and of course the big players, the big incumbents, weren't there yet. So we're only startups. So there was our logo, just
Mhm.
more than 1 million developers watching that conference, and that was our logo. And then the third pivotal moment that goes back to OpenAI, because when they launched ChatGPT,
Mhm.
the 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 question that came immediately in the slipstream of that was like, okay, so how do we do that with our own data? And that was the retrieval augmented generation use case. And so what I was sharing in the beginning about that knowledge graph use case, where we were like, maybe that's like great, we could do something there. And again, keep in mind that this is really early days. But now all of a sudden, we just had a unique use case where like, this is something we can do. We can tailor the product towards that. And I would say that was the third pivotal moment. So those three moments were very important in our history.
Yeah, yeah. I kind of remember you sharing that screenshot on LinkedIn, and yeah, it was
Yeah.
quite breathtaking to see Weaviate there with all these other huge company logos.
I couldn't
Um,
believe it. I was like, I have friends who work at Google, so they started texting me, "You're at the
mm,
keynote." I was like, "Really?" It took me some time to y- I initially I couldn't believe it, but then there it was. Yeah.
yeah, yeah. Wow, came as a surprise to you as well.
Yes. Yeah.
Yeah. And so we've established, there's so much interest in this space. But I want to just dig into why, and or even before the why, what's it even defined as now? Because we started out when you had just created Weaviate, it was vector databases, and we're talking about schemas and search. We're talking about just searching unstructured data. So those were all like the early days. How is it
Hmm.
transformed now? How is the space being defined? What's it being called now? And how have the priorities changed?
Yeah. So that's a great question. So first of all, it became simpler. Um, um, so we've also learned like the way that people are building applications has changed. So
Okay.
the interacting with the database is more as if you're using like a client library, if you will. It's on our homepage. We have like a couple of software examples that nicely illustrate this. So that
Mm-hmm.
has changed. A lot of abstraction went away. Just a lot of abstraction we just don't have anymore. So that's even if you now use our cloud product, you get the embedding services for that are baked in. So you just don't even think about the embeddings anymore. You just throw data at it. Same goes for the generative models and those kind of things. That is something
Mm-hmm.
that we that has changed, and what we did in the how we talk about it. That's also if you go to our website, you see that we don't even have like Weaviate vector database on the homepage anymore. We talk about it as an AI native database, And the
Mm.
reason we do that is because we see a lot of our users and customers, they build end-to-end applications on top of Weaviate. So it's nowadays so much more than just a vector store. That's a thing really from the past for us.
Okay, okay. Yeah, I see it's very AI centric, talking about RAG agents, uh, yeah, AI engineers. So yeah, it is AI, I think, has really changed things up in your space. Um,
Yes.
yeah, so talk to us about is the original use case still relevant? And when we're talking about like search, information search and retrieval, is that still relevant? Is that still a big market, or like is it a decent sized market, or how is that problem still unsolved or still being solved? Comment a bit about that, and then we'll move to talking about the AI use cases.
Yes. So the short answer is yes. So it's like a people baking in the models, and they do that through the vector embeddings in their search use cases. That is something that's still a big thing, right? So a lot of
Okay.
people are building there. You also see a lot of use cases there where you really deal with unstructured data, right? So I don't know. I make this up on the spot, right? But I see like it could be like support tickets or medical
Okay.
documents, that kind of stuff, right? Where it's like really
Yes.
unstructured, where that
Mm-hmm.
works very well. And that's also the hybrid search is being used a lot, right? Where you mix vector search with more traditional search algorithms like BM25 and that kind of stuff.
Mm-hmm.
But that is, I dare to say, almost already outdated. So that's how fast it's going. But we do see a lot of those use
Wow.
cases still. But
Mm-hmm.
that really first wave of use cases. And
Mm-hmm.
then, of course, RAG came out of that, right? Where people say, we want to do all that goodness, and but through a generative model. And the the devil's advocate argument there would be that sometimes people say like, yeah, but can't I do that with any database? The answer is yes, you can. However, it just works so well for these unstructured data sets. And that
Mm-hmm.
mechanism, let's not forget, right? So that if we have a context window in an LLM or any model, the words get turned into tokens and the tokens into vector embeddings, right? So it's basically extending the context window. Or as I always
Mm-hmm.
like to say, I really believe that the vector database is becoming, or at least Weaviate is becoming the context window, right?
Mm-hmm.
And that is a very exciting development. And
Mm-hmm.
then what happened and was, of course, that people started to put that stuff that was coming out of the rack pipeline back into the database. And now all of a sudden we had like that feedback loop. We referred to that in the early days at Weaviate as generative feedback loops, but nowadays we refer to these things as agents, database agents to be precise. And that's the thing that's now the latest and greatest.
All right, all right. Wow. Interesting there. Uh, let's dive a little bit into RAG, because
Hmm.
a lot of people who are building in AI, they are familiar with RAG, and they probably have studied it a bit. But we also want to kind of explain it a bit to those who might be interested, and they've kind of heard the term, but then they're not as familiar with it. If you can explain it for us and break it down a bit, what is RAG, and uh, how does vector databases fit into RAG? What's its role? If you can dive a little bit into that.
Yeah, so the abbreviation RAG stands for Retrieval Augmented Generation.
Hmm.
And if we unpack those words individually, so I always like to do it in reverse order. So if we generate something,
Yeah.
can we augment the generation by
Hmm.
retrieving information from somewhere else?
Neat.
That's the concept. Now, so if you're a developer and you're dealing with the following situation, so you're building an application and you want to do all that great generative goodness that you can do with these generative models. Does By the way, it doesn't have to be limited to text. It can also be images or those kind of things, right? Just let's take, for the sake of argument, let's for change not talk about text, but let's talk about images, right?
Okay.
So now you find yourself in a situation where you want to retrieve something of images, or you want to have images generated uniquely based maybe on
Mm-hmm.
photos that you have stored or those kind of things. You might be a photo platform like, I don't know, like yeah, those stock photo platforms.
Mm-hmm.
Then you're dealing with petabytes of photos.
Yeah.
So how are you going to feed that into the model? Are you going to just have every single individual photo in the context window, like a context window of a couple petabytes?
Wow.
Probably not, right? That's just unusable. It's a
Mm-hmm.
bit dangerous because now you have like all the photos in there. It's very hard to regulate. It's just very inefficient. It's just not a good idea. So what
Sorry to
red?
interrupt.
Yes, sorry, go ahead.
Curious to know what's a traditional way of handling a problem like this, like or a challenge like this? How would these stock photo sites handle that much data and like indexing and searching it? What's a traditional before, let's say, uh, like what it is today?
So back in the day, what you would do is like you would have a photo and you would add metadata to the photo. You would
Right.
index the metadata and then do keyword search on the metadata. So
Yeah.
if you would have a sunset, it would say sunset. And then you could only find it, looking for sun and set or sunset.
Mm-hmm.
But if it would be a sunset where the sun sets behind the Eiffel Tower, then you would only be able to retrieve that photo if in that metadata also the word Eiffel and Tower would be present, right? So you would have sunset Eiffel Tower. Now the
Mm-hmm.
beautiful thing is with the vector embeddings, especially in the multimodal models, is that we throw the photo at that model. The model outputs a vector embedding, and now if you say like I'm looking for sunsets in Paris, it will find that photo for you, right?
Nice.
Even if it does not have that metadata. But now
Yeah.
the challenge is that if I would have a generative model and I would say like, here you have a photo of me and Twain, generate
Mm-hmm.
an image where you see us, in front of the Eiffel Tower during the sunset.
Mm.
Then you need to search through that petabyte photo data set to a photo of like a sunset in front of the Eiffel Tower in Paris.
Mm-hmm.
And so then the very illogical thing of doing that would stuff that all in the context window. So now I have a couple of petabytes of photos in the context window. You have the photo of you, photo of me. By the time the model has processed that, it's just not gonna work. It's just super inefficient. So you can make that
Mm-hmm.
hyper efficient to have like a retrieval mechanism in the form of the vector database that retrieves that right photo, adds it to
Mm-hmm.
that context window, maybe 5 photos that is just like these are the top 5 photos that match that
Okay.
query. And now
Mm-hmm.
we
Mm-hmm.
render that photo. And that's not only happening for image. We decided to take images as an example, but the same goes for audio, video, text. A lot of text, right? A lot of text use cases. So
Mm-hmm.
that's why it's so powerful. And if we double click on it, if you take images, right? So if you stick with images, an image in a context window is like gets a pixel in the image get turned into an embedding, right? And then an array of embeddings. Or in the
Wow.
case of text, the text gets turned into a set of tokens, and the tokens are IDs of vector embeddings. So what you basically do is that you offload the storage of the vector embeddings to an external service, which is in this case Weaviate as a database, and then you retrieve it when you need it. But there's even more. So just think about, let's say that we have if we stick with the photo example, right? Let's say that we have accounts, right? So user accounts with certain photos. You have RBAC mechanisms, right? So you can say Bob can't see Twain's photos and Twain can't see Bob's photos. So if you
Mm-hmm.
would ask like, hey, show me a photo or generate a picture based on this search query, e.g. sunset in Paris, you
Mm-hmm.
wanted to search through your photos, but not my photos, right? That's very hard to do in a context window. But if you
Mm-hmm.
have the embeddings externally, you can just have like good old traditional RBAC for those embeddings. So like Twain is asking this question, so only find embeddings that are owned by Twain.
Mm-hmm.
So that kind of stuff also becomes part of it. So the long and short of it is like it's the vector database like Weaviate is a big context window. That's basically what it is. That helps you to find stuff and retrieve stuff based on the queries that you have.
Hmm. So the embeddings is the context, is it? Or is that even lower level than the context? Is there something that's a layer above the embeddings that is the context?
No, so in the database you have everything. So if you stick with the image examples, you can study the actual image in the database, the one or multiple embeddings that represent that image. You can have like additional data added to it. So you have everything, but you store it and retrieve it based on those embeddings. The embeddings are the first class citizen, and it's like
Hmm.
a had the context window. Well, what's in a name, right? It's a window that gives context to a query,
Hmm.
and you just basically outsource that to an external solution.
Okay, okay. What's the difference in terms of the size of the context? Because you mentioned, each pixel could be an embedding. That would be like a lot. But like, what's the difference in terms of the size difference between like this embedding, the context that is there through embedding and versus the old, uh, like the traditional context that people would use in terms of size or even in terms of performance? What are some of the differences that you mentioned?
Yeah, so here it's easier to take text as an example. So let's say that I have the context Twain talks to Bob. That's just the context that I'm going to work with.
Hmm.
So then I turn that into tokens. I'm gonna assume that that's four tokens, right? Twain talks to Bob, right? Then it everything we do after that, it needs to process those four tokens and those four embeddings. So if we say Twain talks to Bob about Weaviate, then I have even more tokens. So it takes even more time to process. Now,
Hmm.
if we make a whole transcript of this podcast and we put it into the context window, it needs to literally process the whole podcast
Hmm.
to process it. So it's like it's
Yeah.
getting slower and it consumes more power and it consumes more GPU. It consumes more resources. So the thing is like it becomes inefficient quickly. And I'm not
Mhm.
even talking about those things like security and access control and those kind of things. I'm just talking about how the context window operates, and
Mhm.
that's a problem, right? So it's like that's a challenge, and
Mhm.
that's what it solves.
All right, all right. Great. So we talked in depth about RAG. I wanted to get into what you mentioned also about some of the features around agentic AI that's enabled by vector databases. If you could give us some of the top use cases for that and the role of vector databases again there, that would be interesting.
Yeah. So we have a couple of agents. The agent that is by now used the most is the so-called query agent.
Okay.
And if you look at traditional databases, then we retrieve information on keyword matching and those kind of things.
Mm-hmm.
Then with vector search, we had vector search retrieval. The challenge with pure vector search is that it contains only it understands concepts that it is trained on.
Okay.
That is very easily explained based on an example. So
Mm-hmm.
let's say that you have a use case with invoices. So
Mm-hmm.
if my query is show me all invoices with office supplies, easy, great vector search use case because it will
Mm-hmm.
like pens and that kind of stuff, right? It's trained on that, it knows that. But if I
Mm-hmm.
say show me invoices with office supplies, but only for invoices with this type of ID. That is not a good search for vector search. That's a good use case for hybrid search. Because now you
Mm-hmm.
do vector search on office supplies, but you do a traditional search on, or a PM25 search on, in this case, the ID of the invoices. You merge those together, and now you have like better search results through a hybrid search. Now, then that out of that came the new thing that we call agentic search. where
Mm-hmm.
you basically let the agent help you do the search queries, so the hybrid search queries, but also setting the filters so that if you say like, ask the query agent, in which month did I buy the most office supplies? It just starts to query for you, and it changes the date in the date field. It has like it sets like office supplies in like hybrid search, and it
Mm-hmm.
does its thing and it spits out a result. So that agentic search is even better than hybrid search. So that is the use cases that we see for the query agent. And then another agent that I'm extremely excited about, but that is still that's the newest one, and people are still experimenting with that. That is the
Mm-hmm.
transformation agent. So
Okay.
the transformation agent has all that goodness of the query agent, but now
Mm-hmm.
you can ask it to change stuff in your database. So you can say, look at all photos that have no description
Mm-hmm.
and add a description field with a description.
All right.
And that's beautiful. So you run that
Oh.
query, you wait, and now all of a sudden you have a database full of descriptions. It's beautiful.
Mm-hmm. Wow, really interesting. Wow, quite powerful. And those are some of the kind of use cases that we even see, people talking about, even the big AI companies and some of the innovators who are like building end user AI products are talking about these kind of use cases that AI agents enable. And so underlying it all is uh, very often a vector database, and that's really interesting to know.
Yep.
Where do you see a lot of traction in terms of the industries that are really, adopting this at a faster pace, the kind of use cases in those industries? What are you seeing out there?
So the use case we still see the most is RAG. That's what
Mm-hmm.
we see the most.
Mm-hmm.
And but the database agents, the usage grows faster, right? So that's still smaller, but it grows faster.
Mm-hmm.
And what's very interesting to see is that you see new companies that build new products on top of Weaviate's database agents
Mm-hmm.
that they specifically built with the database agents in mind. That is extremely exciting to see. We recently released some case studies around it of the first customers. You often see that in like startups, early growth companies. Enterprises still experimenting with that stuff, but it's very nice to see how that adoption there is growing as well.
All right, all right. Really interesting. So we've got a little demo video to play, but before that, if you could give us like an elevator pitch of what is Weaviate and what are vector databases, and then we'll go into playing the demo videos and get back to our conversation. So what would be the elevator pitch?
Yeah, so the elevator pitch for Weaviate is simple. So it's like every engineer, every software engineer or AI engineer that wants to build AI native applications as fast as possible. So to the agents, the embedding service, what have you. That's what Weaviate is for that group of people. We focus on enablement and making it as easy as possible to go from 0 to 100 in the least amount of time. So we're very
Mhm.
feature rich. We have many functionalities for different types of AI native use cases. So we focus on the engineers that are building end-to-end AI native applications and they want to go to production fast.
Got it. Okay. On that note, let's just play the video. There's two short videos, which is around 2.5 minutes, and then we'll get back to our conversation.
My name is Leonid Eisenstadt. My title is Principal Software Engineer. So Weaviate offered a comprehensive suite of features that FactSet can use as a product. They have re-ranking, metadata filtering, hybrid search, embedding. So this all technical part. Weaviate is running on top of EKS, and we already had a comprehensive EKS subject matter expertise and the team that offered the blueprints for developers. So basically anybody at FactSet could deploy EKS system easily. So adding Weaviate on top of it was an easy solution. So Weaviate offered that solution that our client data would be safe, and secure within the FactSet VPCs effectively. You can bring your own vectors. You can bring your own embedder, actually, like customize embedder. So in the end, it was like a big list of requests or requirements that people wanted to have, and Weaviate kind of fit the bill. AWS offers a great choice with the SageMaker now, with the MLOps and federated queries. For example, we use both Databricks and Snowflake, and now we have ability to subscribe to the data from both platforms under AWS SageMaker Lakehouse and run federated queries. Clients can now ask comprehensive questions through the chatbot and receive answers that required in the past lots of subject matter expertise, programmers, developers, or report writers. This is biggest advantage that we are bringing to our clients. Nowadays, not having an AI solution, it's a big disadvantage to the market. So FactSet is going ahead and bringing the AI solution to our clients as well.
You don't need a server to use a vector database. Weaviate's open source packages let you run a Weaviate instance directly in your code. And here's how to do it. First, we're going to install the Weaviate package. From your terminal, just install the Weaviate client. Then in Python, all you need to do is import Weaviate and create the client by using the connect embedded function. If you need any extra API keys, like OpenAI, you can add them to the headers here too. You can use this just like any other Weaviate client. So you can create a collection, which we're going to call example collection. And we're setting this up so that it uses OpenAI's vectorizer. We can insert any sort of data text into this collection. So we're just going to add 3 random sentences. And of course, we can query this collection using whatever we want. Let's query Lord of the Rings to see if it retrieves the right sentence, which it does. So when embedded Weaviate starts for the first time, it creates a permanent data store locally on your computer. And even if you completely restart Python, our client can still use the collection we set up earlier. So when we query dog, we get the same sentence closest to this query.
View of what Weaviate does. And as you can see from one of the videos there, it's from AWS itself. So it kind of tells, that if AWS is paying attention to this use case, this product, then, it really matters. One of the, I was wondering if we could discuss some of the key features that you launched in recent times. If you could name something that's recently been shipped as part of your platform, your product, tell us what it is and why it's important. There'll be a nice follow-up from the video.
Yeah, so well, obviously the database agents that I just mentioned, but we already talked about those. Might also be interesting to talk a little bit about things that are deeper in the product, so more tech heavy, if you will.
Okay.
We see a lot of usage of our multi-tenancy features. So back in the day, it was very normal to store embeddings just in memory. That was especially for speed. But we see more and more use cases where that actually is too inefficient because then you just need so much memory to store everything in that it's just inefficient. So what we started to do was also introduce different storage mechanisms for the embedding. So not only memory, but also disk. And especially if you fit those into tenants. So for example, for customers who serve other user bases, right? So if you have a platform and you have like 1,000 customers, then that would mean 1,000 tenants inside Weaviate, right? And now you can manage these tenants individually. So you can move them to memory, you can move them to disk, or if you're not using them at all, you can offload them to S3. And of course, that has like cost implications. And that is what we see, like the power users of Weaviate use all those kind of features, and that's really nice to see. That's very cool.
Multi-tenancy, interesting.
Yeah.
Yeah, that's really cool. As we wind down, I've got a couple of rapid fire questions for you.
Shoot.
Just tell me what comes to your mind.
Yeah.
What's one misconception that people have about vector databases?
Yeah, that it's only storing vector embeddings. That is just vector search.
Okay, all right. And you told us a lot about just all that can be done with it in the past few minutes. All right, the next one. One thing that teams should stop doing immediately, and is probably a sign that they should consider a vector database?
Oh, they the thing that they should stop doing, and it's like shoehorning stuff in, right?
Okay.
Or just, we see a lot of engineers that are like forward leaning and innovative and curious about what's new. They are like the early adopters, but they also
Mhm.
just move fast, right? So it's like I would encourage people just to give it a try, and then they'll enjoy it. If they have an AI case, they'll enjoy giving Weaviate a spin.
Mhm. And it's really easy to get started. You even got like an open source
Yeah.
uh, project. All right, next one. What, so kind of wear your product manager hat for this. What's one lesson you learned about product building? I'm sure there's many, but if you were to think of just one of them, what would it be?
Naming. So it's like back in the day, um, we wanted to be unique. So we came up with names that were not aligned with industry standards.
Okay.
Or if we made something, if we created something before there was a name for it. So a very simple example is like, we are already working on those agents for 2.5 years, but they weren't called agents back then. So we called them generative feedback loops, or
Okay.
GFLs for short. So we
All right.
really learned like you should not stick to that. So because otherwise customers get confused. So then
Mm-hmm.
if the industry just has a different name for this, then just adopt that. And so if you I there's like this knee-jerk reaction of that you want to be unique and therefore give stuff unique names. But if
Mm-hmm.
you have too many unique names, then people get confused about what something
Mm-hmm.
is. So that's what I would answer, like naming conventions. Be smart about
Right.
that.
Right. Yeah. Yeah. Anything you'd like to mention as like a side note to how you came up with VV8?
Yeah, so that's about weaving the model and the data together. So weaving it together.
All right. All right. Neat. What's one most underrated capability of vector databases?
Uh, then I have to make it specific again for us, because yeah, this is a unique feature that we have, and that I would say that transformation agent. Every time when I demo this to customers or they go like, "Whoa!" Right? And that's
Mhm.
like but it's so new, like that for the first time in history that the database has an opinion on your data and can help you solve problems. That is
Mhm.
very new, and that people get very excited about that.
Wow. And is there also part of the open source project that people can go and try out?
No. So we've decided for a variety of reasons that the database agents, they sit in our cloud. So you need to use our cloud product to get access to them.
Okay.
But you can just also start that for free. So you can just
Okay.
spin it
Okay.
up and just start to play around with it.
There's a free tier. Okay.
Yes, yes.
Neat. Last one. How would you explain vector databases to a 10-year-old?
Uh, if you would be sitting at a table and there are like all these things on the table, so maybe you see like a glass of water. You might see a pen, you might see a notebook. How would you rearrange these things on the table and how they're related to each other? So you
Mm-hmm.
might lay the pen next to the notebook, but you
Mm-hmm.
may do the glass of water maybe a little bit further away, because, pen and a notebook don't really have a relation to each other.
Mm-hmm.
That's how the vector embeddings work, right? It's not happening in 2 dimensions, and it's happening in many dimensions.
Right.
But conceptually, that's what it's doing. It's organizing stuff in a space.
Mm-hmm.
So in this case, the tabletop,
Mm-hmm.
in
Wow.
how these things relate to each other. That's how I would explain it to a 10-year-old.
Wow, that's an excellent example. I feel we should have started with this first.
Yeah, yeah.
Uh, But yeah, fascinating conversation. But the last question I have for you, Bob, is just looking ahead the next year or so, what's on your mind? What are you reading up about? What do you think is the next big thing? And yeah, just give us a little glimpse into 6 months to a year down the line, what we should be probably keeping track of.
Yeah, so if you don't mind, I'll give you two, and I'll give you two at the both ends of the spectrum. So the first one is like the agentic stuff. So we're doing a lot of stuff there that we're releasing in the database to enable developers, right? So with new types of agents, improving the existing agents, and that kind of stuff. So you will see a lot of stuff there. On the other side of the spectrum, so that's really in the nitty gritty core of the database. The super intelligence team from Meta, they came out with their first research paper, something called RAG, where
Okay.
they just it's like RAG on steroids, and it's like a that of course made me very happy because the whole story that I was just telling, that whole spiel about like the how the Weaviate is becoming the context window.
Mm-hmm.
They're kind of saying that in their research paper as well. And that is something that I'm also very excited about. So I would say those two things on the far ends of the spectrum.
All right, all right. Neat. Yeah. Could go and check out those things.
Nice, huh?
With that, yeah, with that we come to the end of this conversation. I think it was quite a fascinating conversation, a kind of whirlwind tour of just all that's happening with vector databases, and especially some really interesting overlaps with AI, and especially the agentic stuff that you mentioned, data transformation. So a lot to go and read up on, and to catch up with after this conversation as well. So thanks so much for joining us, Bob. Thanks for sharing your insights. It was a real pleasure chatting with you.
Yeah, and man, it was great seeing you again. And so for your listeners, you are an OG. You were like at the early days writing about this stuff. So it's great to see you again. So thanks for having me.
That's really generous of you. And thank you to all of our listeners and viewers for tuning in as well. We hope you enjoyed this conversation as much as we did having it. Go and check out what Weaviate is up to. Their website is weaviate.io. And you can also go and follow Bob on LinkedIn. He's got a lot of followers and posts some really cutting edge stuff on LinkedIn and some really interesting updates in the space. Go and check out their open source project or even their free tier that Bob mentioned, where you can play around with some of the agentic AI stuff. And tune in again for the next conversation, because we love having this conversation and we'd love to have you with us on the ride. See you on the next one. Bye bye.